Part 2, Young's double slit experiment, looking at test questions. Question 3, find the distance between adjacent dark spots from a double slit diffraction pattern if the wavelength is 500 nanometers, the distance between the slits is 1 millimeter, and distance from the slit to screen is 2 meters. We have our givens here, the wavelength, the distance, and the length between the screen. We're hunting for the distance between two slits, that's y. And again, I'm going to draw a quick diagram off to the side so I remember what all of these different variables mean. Drawing my diagram, I have to make an assumption that the distance between the dark spots is equivalent to the distance between the bright spots. And that's true, so it's not a bad assumption at all. Once I've got that straightened out, I've got to convert everything into the right units and get my equation down, which I've got done now. Notice I converted nanometers and millimeters all into meters, so I'm consistent in my distance unit. Now I just have to plug in the numbers into the equation and work out my answer. I'm being careful to include meters, my units, in the equation to make sure that I have converted everything correctly. And then with my final answer, meters over meters cancels out, and I have 1 meter left, so it's 0.001 meter. Problem 4. A diffraction grating with 12,000 lines per centimeter creates a bright line at 24.5 degrees away from the central bright line. What is the wavelength of the light? I'm writing down my unknowns. Notice I'm very careful to put down exactly what it says, 12,000 lines per centimeter, not putting down what I want to hear it or what I want it to be. And I also, of course, write down my unknown. Now I have to work on that 12,000 lines per centimeter. If I take 12,000 lines per centimeter and invert it, I get 1 centimeter for every 12,000 lines, although of course I converted centimeters to meters right away. Now, if I just solve that mathematically, I will find out the distance I have between the lines. And that distance is 8.33 times 10 to the negative 7th meters per line, which is d, the distance between my spacing. Now it's just a matter of writing down my formula, rearranging my formula for the correct thing, and plugging and chugging in my numbers, being careful to make sure that I look at the units. With my units done, I can put it in the calculator and I get my final answer, 3.46 times 10 to the negative 7th meters, which I then convert to nanometers. That would be 346 nanometers. This problem gives us the slit width and the distance to the screen, but there's something different. The distance between the positions of zero intensity on both sides of the fringe is 4.1 millimeters. Find the wavelength. We need a sketch. The problem said that it was diffracted by a slit. A slit is a single slit diffraction. When we're talking about single slit diffraction, we're talking about the minimums being that distance y away from the center maximum. And that's how you satisfy the equation. So that 4.11 millimeters is for the two minimums distance away from each other. That sketch really helps. So again, the distance between the positions of zero intensity is the minimums, which is 2y. So if 2y is equal to 4.10 millimeters, then y, of course, is equal to 2.05 millimeters. And of course, we still have to convert everything to meters so that we are in the same unit. So I converted y to meters. Now I'm going to take d, remember d is my slit width, and change that to meters. Write down my equation, plug in my numbers, and solve the problem. And of course, what did I forget to do? I forgot to put down what my unknown was. So I'm going to go ahead and correct that and put up what I'm hunting for up to the side, and then plug my numbers in. There was also that other assumption that I forgot to explicitly state, m is equal to 1. Other than that, it's just very straightforward. And voila, I have my answer. The wavelength is 5.47 times 10 to the minus 7th meters, or 547 nanometers. And thus ends this part of the test review. The next questions were the thin film questions. Thank you very much for your time.